model is a means by which we can explore the real thing as a replica. Now, models actually come in lots of different flavors. And let me give you an example of what's known as a conceptual model. And many conceptual models embrace the idea of rulers and clocks as tools of exploration and tools to bridge to the familiar. And a conceptual model really takes some complexity about our world and makes it understandable. And so let me give you an example. The sun is 93 million miles from the Earth, our star. I don't know what that means. I don't know what 93 million miles means. It's a number I can memorize in a classroom, and you can ask on an exam, say, how far is the sun from Earth, and Sarah remembers where she stored that information and puts 93 million miles down or 150 million kilometers down. She gets an A, and no learning has taken place because it's just a number to memorize. But you can build a conceptual model. If you were to talk to, say, a fifth grader, 10 years old, and say, okay, is a commercial jet fast, a jet that you get on in the airport? They'll say, yeah. Well, it's about 600 miles an hour. That's 10 times faster about the typical speed limit on the highway here in the U.S. That's faster than a race car on a racetrack. It's fast. And if I could travel to the sun at the speed of a commercial jet, it would take me 17 years to get there. And if I ask that 10-year-old, that fifth grader, well, how old will you be by the time you get back? They'll say, well, I'm 10 now, 17 years, I'll be 27. And then you ask the really key question, well, did you forget it'll take you 17 years to get home? And they say, oh, I'll be 44. And then you ask one last question, would you be an old person? And they say, yeah. And a lot of teachers don't like that. But the point, though, is that I can make 93 million miles understandable by building this conceptual model which bridges to the familiar, a plane, the passage of time that is relative to my life, something understandable. And if you ask that same child, if you ask a student, well, is the sun far? They say, of course it's far, but it's not. The sun is incredibly close, which says something about the majesty of the universe and the distances to the other stars. Here's another conceptual model. If I were to put my arms up like this and ask all Americans to do the same, I'm in the U.S., so let's use the United States as an example. If I were to ask all Americans to do this and line up, so Carlos here, go like this, and we line up like this. So come on, you got to come into Pam a little bit, okay? Line up like this, and we have all Americans line up so that their fingertips are to fingertips. How long a line would I make? Well, you'd make a line that could stretch around the entire planet Earth 12 times. That's what 300 million Americans means. And that's a pretty powerful statement. Let me give you another one. Human race, it's everywhere. Human race, it's changing our world, the environment. It must be this massive biological entity. If I could take all human beings and bring them into one place, hey, come on over here, and I build a box to hold all human beings, how big would that box be? Well, it turns out, and I live in Washington, D.C., and many of you know Washington, D.C., it turns out that I could put almost 7 billion human beings in a box, a little tiny bit bigger than the National Mall in Washington, D.C., up to the top of the Washington Monument. A volume of space where the footprint is one street wider on both sides of the National Mall, which runs from the U.S. Capitol down to the Lincoln Memorial, and up to the top of the Washington Monument. That's it. That's the whole human race. If you're a New Yorker, I grew up in New York, so I know this. Not that every New Yorker knows this. You could fit the entire human race in Central Park up to the top of the Flatiron Building. And in fact, I wrote a blog post on Blog on the Universe where you can explore how big a volume the human race takes up in your area of the world. But the point is that this conceptual model says the human race is this tiny little thing. And how is it that this tiny little thing has the ability to impact the entire global environment? Because this tiny little thing, which is mostly water, has intelligence. And we're capable of building tools. And with those tools, we've developed a technology. And it is our technology that has the ability to change the environment. which, by the way, is one of the best arguments for science education, so that an informed citizenry can make informed decisions about how to use technology. But again, this is a conceptual model that gives you a deeper understanding of what 7 billion human beings really mean. A final thing that I'd like to say is that there are numerical models. And so if you're a student, the report card that you get home from school with grades, if they're number grades, even if they're letter grades, but if they're number grades, those grades provide a sense of how well you've mastered different subjects. And if you're an adult, every month you have to pay your mortgage or your rent or pay something else, you whip out your checkbook, and your checkbook is a numerical model of your net worth, at least in liquid cash. And so that checkbook is sort of like a spreadsheet, a numerical model of how much money you have on hand. And anything virtually that you can put in a spreadsheet with numerical modeling is a numerical model of some aspect of the world. So there are physical models, there are conceptual models, there are numerical models. Models come in lots of different flavors. What they have in common is they're a means by which we can learn about our world in a creative way. So let me stop there for segment number 2 and see if there are any questions.
That was great, Dr. Goldstein. We totally appreciate that. We do have one question that came in, and I believe you mentioned Charles Lindbergh's flight was in 1927?
Yes, it was 1927, and the two questions that came in are what was the date of the flight, and what was the average speed? And let me be a science educator for a minute here and say something that's really, really important, which is I don't know, and that's okay. And if this was my class and I was getting this question, I would say to the class, you know what, I don't know, but we will find out together. It's a question that you asked. I don't know the answer, but we can find out together. On the other hand, it's also interesting that it's very easy to find that answer out because I would just Google it, and Wikipedia, which is what you're doing right now, right? So he's zipping along here. Yeah, the Ortig Prize, and May 20th, 1927, but we'd have to dig out the average speed. But it was 33 and a half hours for the flight, so you could take the distance from New York to Paris, and you can Google that too, and divide by 33.5 hours to get the average speed. But let me point out something that's important here. If there was ever a doubt about whether or not memorization of information was what education should be, that doubt has been completely erased by the internet. Information now is virtually worthless because information can be obtained on the internet virtually at light speed. And so is education really about memorizing a book of knowledge? No. It never was. There were incentives for that to be the case, but it never was. And in fact, a teacher many years ago said, I'm frustrated because I'm being asked to shove 5 gallons of water in a 1-gallon bucket. And I think teachers out there listening to this know what I'm saying. And my answer to that teacher was, well, stop doing that because you can't do it. It's not about teaching the book of knowledge. What is valuable today and what the internet shows us is that the power resides in what you do with knowledge. The mind was not designed to be simply a sponge of information, but to process information. And education needs to be about critical thinking.